Now coming to the chemical properties of amines. Now amines, as it is basic in nature, definitely it will react with acid to form salt. Alright, as amines are basic in nature. For example, C2H5 NH2, when it reacts with HCl, it gives you C2H5 NH3 plus and Cl minus. We can say that. Similarly, this further will react with HCl. Further will react with amines, not HCl. C2H5 NH3 plus Cl minus plus C2H5 NH2. Let us say. What you will have? You will have C2H5 whole twice. You can see two molecules of C2H5. Then C2H5 whole twice. NH. Okay. Here it is NH2, of course. NH fine, and it will be HCl. NH plus Cl minus, because nitrogen one bond with C2H5, two bonds with C2H5, one bond with H plus, and you will be getting nothing but that is Cl minus, so to say. So in this way, that is you will be getting that is C2H5 whole twice, that is NH, you will be getting here NH2, here also NH2, so C2H5 whole twice. Let me also write it in this way, that will do C2H5 whole twice, NH2 whole twice, C2H5 whole twice. So instead of writing C2H5 whole twice, I can write C2H5 NH2 whole twice plus here 4 hydrogen, here this what you can say 5 hydrogen, here C2H5, here 2 C2H5, done. So here you can see 4 hydrogen, here H plus and Cl minus. Now it is okay. You can get it in this particular way. Fine. So in this way, it will further react with C2H5 NH2 to form, that is nothing but another salt, we can say that. That is nothing but C2H5 whole N, C2H5 N whole thrice. We can say H plus and Cl minus, you will be getting it in this way. Similarly, aniline also reacts with HCl. Aniline also reacts with HCl. We can say plus reacts with HCl to form anilinium chloride. NH3 plus Cl minus. Anilinium. This is your anilinium. What I said? Anilinium chloride. Let me write the I properly. Anilinium chloride, we can say that. Alright, it is ethyl ammonium chloride, we can say. This one is. It is diethyl ammonium chloride, we can say that. Clear? In this way, you will be getting it. Now, it also reacts with metal ions. For example, C2H5NH2 plus AgCl. Let us see. A metal chloride I have taken it, AgCl. So, what will happen is that here you will be getting C2H5N 1 Ag. It will give, nitrogen will give a pair of electron to Ag. Then C2H5 N, it will be another C2H5. Let me write here N, that is better. N, then here it is C2H5. Clear? So here it is, we will see now, we will balance it. C2H5 NH2, so 2 molecules we require. So 2 molecules of C2H5 NH2. Now here NH2 of course will be coming. C2H5 NH2. Here also same thing. NH2 C2H5. Then plus, and outside the bracket I am writing it below, that is Cl minus. It is actually, it should be at the side. Let me write it the side only, otherwise you people will get confused. Plus and Cl minus. Now it's okay. So in this way, you got this particular, what you can say, salt, you will be getting it. That is nothing but it is bis. Two times it is there. Bis. That is ethylamine. Then silver 1 chloride. We can say that it's a soluble salt. It's a bis ethylamine silver 1 chloride, I should say that. Clear? So in this way you will be getting with metals also, it reacts, that is with metal chlorides or metal sulfate like copper sulfate, it will react to form what you can say tetra methyl ammonium, what you can say copper sulfate, we can say it is going to form. Clear? So in this way with copper sulfate it will react like CH3NH2, 4 molecules, 4 molecules of CH3NH2 plus CuSO4, it will be nothing but NH3, that is CuCH3NH2 whole 4, it will be tetra. Alright, so this nothing but, again I repeat, CuCH3NH2 whole 4 whole 2 plus, then SO4 2 minus. That is what I want to say you in this way. That is Cu, got it? That is CH3NH2 whole 4 2 plus and SO4 2 minus. For that reason what I need to do, CuSO4 and 4 molecules of CH3NH2. 4 molecules of methylamine reacts with copper sulfate to give you tetramethyl ammonium copper sulfate, we can say that. Clear? You will be getting it. Or tetrakis, we can say tetrakis, like it is bis, here it is tetrakis. Got it? Then methylamine ammonium copper 2 sulfate. Got it? Tetrakis, then within bracket it should be methylamine copper 2 sulfate, we can say that. Clear? In this way, this also is a soluble salt which is blue in color. This is a soluble salt, we can say that, which is colorless, and this is soluble salt which is blue in color, so to say. So in this way it also reacts with halides. Alright, it also reacts with halides, and when it reacts with halides, what it forms is that it forms again that is exhaustive halogenation takes place and it forms a salt, we can say that. Clear? So it reacts with halides, so to say. Fine. So hence what you find is that it will react with halide. So it reacts with halides. Halides means, for example, here it is RNH2, let us say, plus Rx, we can say that. Clear? So what you will be getting? It is nothing but RNRH. This is your 1 degree amine. It reacts to form 2 degree amines. This H and this H X to form HX. We can say that. Clear? I have removed it. This hydrogen actually I have removed. So I have showed it here, this particular hydrogen. Don't get confused. And again it reacts with Rx. It will be forming RNR. Okay. And here it is HX. We can say that. Clear? Again it is going to form, again it is going to react with Rx to form R4N plus X minus. So in this way, exhaustive alkylation takes place. Like here, if you take methyl chloride, so exhaustive methylation we can say. If you take ethyl chloride, you can say exhaustive ethylation, we can say that. Clear? So in this way, whatever the halides you are taking it, whether it is methyl chloride or ethyl chloride, whatever the halides you are taking it, accordingly, respective compounds you will be getting it accordingly. I hope you understood this particular one. So this is primary amines, it will give you secondary amines and tertiary amines and quaternary amines, we can say that we will be getting it. Now next is, this also can be done with what you can say aniline, also it can be done. It also can be done with aniline, we can say that. How? See here, benzene ring NH2, same thing, in place of R we will be using, that is nothing but here, that is benzene ring. In place of R I have used benzene ring. Alright, plus Rx, so to say. So what will happen? One H will be replaced by R. So it is N, H and R, we can say that. Clear? N, H, R, we can say that. Suppose if R is CH3, let me put here something. Like suppose if I take here CH3Cl, so what will I get here? I will be getting here CH3 and here I will be getting HCl. Finished. Here HCl you will be getting it. Again it reacts with CH3Cl to form what? you will be getting, that is nothing but NCH3 whole twice, and again here it is minus HCl. You will be getting it. Clear? Again it will react with CH3Cl. This will again react with CH3Cl. We can say that. And what you will be getting it here? Let me make it shorter, this one. It will be CH3 whole thrice, CH3 whole thrice N plus Cl minus. What I said, again it will react with CH3Cl, this one. So you will be getting CH3 whole thrice N plus and Cl minus, you will be getting it. Finished. So this is the different types of anilinium compound you are getting it. What I said, anilinium. For example, this one is N-methyl aniline. It is N-dimethyl aniline. We can say that. Clear? You will be dimethyl aniline. Then it further reacts to form, that is trimethyl. Got it? Trimethyl anilinium hydrogen chloride. Trimethyl anilinium. Why it is linium? Because positive charge is there. Trimethyl anilinium hydrogen chloride, so to say. Clear? So in this way we are getting it. Also you can also say trimethyl anilinium chloride. We can say that also can be written to be as. Now next is, we'll come to Hofmann's elimination reaction. Hofmann's elimination reaction, so to say, we'll come to. So what I said, Hofmann's elimination reaction. In this particular reaction, what we generally do is that, for example, CH3, CH2, CH2, and here let us say C2H5, here that is your CH3, let us say, we will be having it, and here we will be taking another, let us say CH3, got it, and plus I minus, that is we are taking a quaternary salt, we have taken. A 4 degree amine I have taken, a quaternary amine I have taken it, a quaternary salt. When it reacts with moist Ag2O, Ag2O moist, when it reacts with. Actually, moist Ag2O means what? I have said you earlier also, it is nothing but AgOH. Moist Ag2O means AgOH. Then you must be saying, why we don't write AgOH? Because AgOH actually does not exist. It exists as moist Ag2O only. Because AgOH does not exist, so to say. So then what will I get it? Just this I minus will be replaced by OH minus, so to say. This I minus, that is CH3, CH2, CH2, here it is N, here it is CH3, here it is CH3, it is CH3 plus OH minus, and here you will be getting it as AgI, as a secondary product. As a secondary product you will be getting to be as AgI. Okay. Now why it is called as Hofmann's elimination reaction? Because now you see it is substitution. No elimination is taking place. Now you will see the elimination. What we'll do is that I'll be heating it to a temperature of around 400 Kelvin. I'll be heating it. Alright? I'll be heating it to a temperature of around 400 Kelvin. Now when I'll be heating it to a temperature of around 400 Kelvin, what is going to happen? Here, that is the cleavage is going to take place here. The cleavage is going to take place here. When the cleavage takes place here, what you will be getting? You will be getting an alkene. Yeah, you will be getting an alkene. And here you will be getting tertiary amine. We can say that. Plus water will be released. How water? Because alkene, when it is being formed, means double bond, it comes here. So from your hydrogen, H plus ion, this H plus ion reacts with OH minus ion to form water. Again I repeat. Here when I will be heating at 400 Kelvin, what happens? This cleavage takes place. Why the cleavage takes place here? Because this is a bigger alkyl group. For that reason I have written it. It's a bigger alkyl group. So wherever the bigger alkyl group is there, definitely the bond will be a weaker bond. Definitely. So hence the cleavage takes place here. Hence what you will be getting, as I said, see here, CH3, CH double bond CH2. So when it forms an alkene, H plus ion is released from here. H plus ion is released. You can see there, CH3, CH double bond CH2. So here when H plus ion reacts with OH minus ion to form what? Water. For that reason it's called elimination. Because a smaller molecule is eliminated. Alright, whenever some smaller molecule like water, HCl, ammonia, SO2, NO2, CO2, alright, these are eliminated, they are called as elimination reaction. And in case of elimination reaction, from single bond it gets converted to double bond. From saturated it becomes unsaturated. See, from saturated it gets unsaturated. And what more you will be having? You will be having CH3 whole thrice N. We can say that. Clear? Trimethylamine you will be getting it. So hence it is called as Hofmann's elimination reaction. It is said to be as. Alright. Now we will see the reaction with that is acid chloride. Clear? So this is your Hofmann's elimination reaction. Again I repeat, Hofmann's, Hoffmann''S, Hofmann's elimination reaction. Next, that is nothing but CH3COCl, acid chloride, reacts with CH3NH2. Alright, CH3COCl reacts with CH3NH2. What is going to form? So here HCl will be released. From here one H and here one Cl. HCl will be released. And what is the remaining product? Remaining product will be CH3CO, then NHCH3. NHCH3 plus HCl. CH3CO, NHCH3. I said from here one hydrogen and here one Cl. So HCl will be released. CH3CO, NHCH3. It is nothing but what is the name? N-methyl ethanamide. Ethanamide. 2 carbon is there. N-methyl ethanamide or N-methyl acetamide. We can say that. Clear? So you can do this reaction with ethylamine also. You can do this reaction with secondary amine also. You can do this reaction with tertiary amine also. The reaction can be done. Alright. So with primary amine I have done it. With methylamine I have done it. As I said, you can do with ethylamine the same reaction. Instead of here it is CH3, that is NH2, you will be getting here NHC2H5. Here you can take that is secondary amines like C2H5 whole twice NH you can take. You can also take C2H5 whole twice N. So this part is going to change. We can say that. This part is going to change because this part is constant. Because I have taken CH3COCl. This part is constant. So this part will be the same. This part will be the same. Only this part is going to change. When you are taking ethylamine, then secondary amine, tertiary amine, this part is going to be changed. That's all. We can say that. Now this reaction also can be done with that is nothing but what I said, aniline. It also can be done. So what you will be getting it here, aniline means what it is? It is nothing but C6H5NH2, that is aniline. So here also same thing. Here and what will you get? C6H5. That's it. Clear? You will be getting C6H5. So it is nothing but known as acetanilide. This is known as acetanilide. That is N-phenyl. It is N-methyl. Previously methyl was there, so N-methyl I said. It is now N-phenyl. N-phenyl ethanamide. N-phenyl ethanamide. 2 carbon eth. Same thing it is. Just this part is changing now. So it will be ethanamide, no doubt about it. But it is N-methyl, N-phenyl, what you can say, ethyl or N-methyl, whatever it is. This part is changing. So it is N-phenyl ethanamide, and the common name is acetanilide. We can say that. Acetanilide. Acetanilide, we can say that. Clear? In this way. Here it is CH3. CH3COCl. This is acetyl chloride. This of course you know that. It is acetyl chloride or ethanyl chloride. We can say that. Clear? Now, here also we can change the group. We can change it and we will see it. Let me rub it first. So here what will I do? Instead of acetyl chloride, I will take benzoyl chloride. I will be taking it. What is going to happen? Benzoyl chloride. If I take C6H5COCl plus C2H5NH2. What is going to happen? Same thing is C6H5CO. There it was CH3CO. Here it will be C6H5CO. Where to write? Here I am writing C6H5CO. This will be fixed. Then it will be nothing but NHC2H5. Alright, plus HCl. That's it. Alright, so the compound is nothing but N-ethyl benzene amide or benzaamide. N-ethyl, see here, naming is same, N-ethyl benzaamide, because this is your benzoyl chloride. This is benzoyl chloride, and this is your ethanamine. It is N-ethyl benzamide or benzenamide, we can say that. Now this reaction is quite slow. Got it? Because I said you that aryl, basically aryl compounds are quite slow. Got it? It does not undergo nucleophilic substitution reactions readily. For that particular purpose, I have to take a catalyst here, which is nothing but a basic catalyst, that is pyridine, because this is acidic in nature. So hence I will be using a basic catalyst, that is pyridine. So in presence of pyridine, you can see the reaction can be carried out. We can say that. Clear? So here also what we can do is that I can take here C6H5, I can take it here. So what will I get? I will get C6H5 here also. So what is the name? It will be N-phenyl benzamide. N-phenyl benzamide, or we can say benzanilide. We can also say benzanilide. We can say that. Either we can say N-phenyl benzamide or we can say benzanilide. We can say that. Clear? So this is otherwise also called as benzoylation. We are doing the reaction with benzoyl chloride, so it is also known as benzoylation. Now here you need to remember that if I do the reaction with NaOH instead of pyridine, aqueous NaOH if I take, then this reaction is said to be as Schotten-Baumann reaction. Schotten, S-C-H-O-T-T-E-N. Schotten-Baumann reaction. B-A-U-M-A-N-N. Schotten-Baumann reaction. When it will be, listen carefully, instead of pyridine, if I take aqueous NaOH, aqueous caustic soda, aqueous NaOH if I take, then it will be called as nothing but Schotten-Baumann reaction. S-C-H-O-T-T-E-N. Schotten-Baumann reaction. Okay, it is known as. Now next, space is there. So what will I do? The next is I will be taking here, that is RNH2 plus any that is nothing but aldehyde I can take, or any ketone I can take it. Alright, RNH2 plus aldehyde. So aldehyde is nothing but RCHO, or we can say R-CHO. I can take same alkyl group or different alkyl groups. Why did I write in this way? You can see very clearly. Water is released. Alright, water is released. Now this reaction is done in presence of a medium. Which medium? Acidic medium. This reaction is being done in presence of acidic medium. Now remaining product, we write it down. RN double bond C, here is H and here it is R, plus water, it is released, we can say that. Now this is what? It is a Skips base or anyl. Skips base or anyl, we can say that, not anil, anyl, we can say. Skips base or anyl. Now we can also do the reaction with ketone. We can do the reaction ketone. Let us say I will be using another R here. This is your ketone. Clear? So hence you will be getting, here it is R. So it is also known as Skips base or anyl. Whether you react with aldehyde or ketone, it is the Skips base or anyl. It is known as common name, general name, we can say, not common name, general name, we can say that. If you do with aldehyde and ketones, then the name is going to vary. Of course, it is going to vary. The name is going to vary. But otherwise, it is known as Skips base or anyl, we can say that. Clear? So next is we can also do this reaction. Suppose the Skips base or anyl, which you will be getting it. Like let us say I am doing this reaction with what will I do? That is C2H5 NH2. Let us say I am taking it here, plus that is CH3CHO. Let us say I am taking it here, CH3CHO, aldehyde. Alright, I have taken acetaldehyde, this one, and this is your ethylamine. I have taken it. Now what will happen? Water will be released. In presence of H plus, water is released. So what I got? I got C2H5 N, then double bond C H, then it is here CH3, and water is released. We can say that. Clear? Now you see what is going to happen. Now this particular compound, if I react with Rann nickel in presence of hydrogen, means if I go for reduction, this particular compound, if I go for reduction, reduction means what I said, here you will be using a catalyst, that is nickel in presence of hydrogen. Which nickel I said? Rann nickel, we can say that. A particular kind of catalyst, we can say that, nickel which contains copper as another substance present in it, that is called as Rann nickel, so to say. Clear? It is a better catalyst compared to that of nickel, we can say. That is called Rann nickel. So hence what is going to happen here? What is going to happen? So what I am going to see it here, that is double bond will be broken down, it will form a single bond. That's it. Double bond will be broken down, it is going to form a single bond. Clear? And hence what I am going to get the product is nothing but CF, C2H5 and H, here it is, single bond H. Then here it will be CH2, already one H is there, another CH2, CH3. Another H will be added, CH2, CH3, and here it will be another hydrogen is added. One hydrogen added here, one hydrogen is added here. Alright, so double bond is removed. So here you can see the product. So you get what? You get diethylamine, a secondary amine, so you are getting it. Diethylamine, a secondary amine, you are getting it. We answer that. Clear? In this way. Now next is we will see the reaction with nitrous acid. In the next AB we will see that. Thank you.